Class 7. Animated Math. Introduction. Line. In earlier classes, we have studied different lines, line segments, and angles in a given shape. Let us revise them. Line segment. A line segment has two endpoints. When extended endlessly in both the directions, it is called a line. Ray. A ray has only one endpoint. Angle. An angle is formed when two line or line segments or rays meet. 2. Related angles. 2.1. Complementary angles. When the sum of the measures of two angles is 90, the angles are called complementary angles. Examples. These are the examples of complementary angles. 2.2. Supplementary angles. When the sum of the measures of two angles is 180, the angles are called supplementary angles. Examples. 2.3. Adjacent angles. Those angles which have a common vertex, a common arm, but no common interior points are called as adjacent angles. Examples. 2.4. Linear pair. A linear pair is a pair of adjacent angles whose non-common sides are opposite rays and which are supplementary. Examples. 2.5. Vertically opposite angles. When two lines intersect, the vertically opposite angles so formed are equal. Examples. 3. Pairs of lines. 3.1. Intersecting lines. When two lines L and M meet, we say they intersect. The meeting point is called the point of intersection. Example, as shown in figure. Where lines drawn in a sheet of paper do not meet, however far produced, we call them to be parallel lines. Example, as shown in the figure. 3.2. Transversal. A line that intersects two or more lines at distinct points is called a transversal. Example, as shown in figure. 3.3. Angles made by transversal. We can see in the figure given below that P is a transversal on lines L and M. It makes 8 angles with them. Look at the table given below. It shows special names given to various angles formed by the transversal. Interior angles. Angle 3, angle 4, angle 5, angle 6. Exterior angles. Angle 1, angle 2, angle 7, angle 8. Pairs of corresponding angles. Angle 1 and angle 5, angle 2 and angle 6, angle 3 and angle 7, angle 4 and angle 8. Pair of alternate interior angles. Angle 3 and angle 6, angle 4 and angle 5. Pair of alternate exterior angles. Angle 1 and angle 8, angle 2 and angle 7. Pairs of interior angles on the same side of the transversal. Angle 3 and angle 5, angle 4 and angle 6. Now try to understand these special names. Corresponding angles. These have different vertices, are on the same side of the transversal, and are in corresponding positions above or below, left or right relative to the two lines. Alternate interior angles. These have different vertices, are on opposite sides of the transversal, and lie between the two lines. 3.4. Transversal of parallel lines. We know that those lines on a paper which do not meet, however far produced, are called as parallel lines. Transversals of parallel lines give rise to very interesting results. The results are as follows. If two parallel lines are cut by a transversal, each pair of corresponding angles are equal in measure. If two parallel lines are cut by a transversal, each pair of alternate interior angles are equal. If two parallel lines are cut by the transversal, then each pair of interior angles on the same side of the transversal are supplementary. 4. Checking for parallel lines. If two lines are parallel, then you know that a transversal gives rise to pairs of equal corresponding angles. Equal alternate interior angles and interior angles are on the same side of the transversal, being supplementary. When two lines are given, is there any method to check if they are parallel or not? We can do this in three ways. When a transversal cuts two lines such that pairs of corresponding angles are equal, then lines have to be parallel. When a transversal cuts two lines such that pairs of alternate interior angles are equal, then lines have to be parallel. When a transversal cuts two lines such that pairs of interior angles on the same side of the transversal are supplementary, then lines have to be parallel. Class 7 Maths, Chapter 5 Lines and Angles. Animated Math. Introduction.